Okay, this is question 1 of the probability paper. We've got Hank Soloist, and his computer is telling him about the odds of survival when he's being pursued by his enemies. He's got three options. He's flying into the asteroid field, outrun the other ships, and then fly directly at the ship chasing him. So I've highlighted the key information and see the asteroid field. I've got a probability of 0.42, and the outrun the enemy is 0.46. So I've color coded those and I've put them on a tree diagram, and I knew I had to do a tree diagram because there was one thing followed by another. Different actions had an effect of either survival or not survival. So you can see how I put up the tree diagram, and I've just put the information from the question on there. You can see in the yellow there, I've got the asteroid field 0.42, and then survival of that is 0.15. And I've got the 0.46, and so from there, because I know that those branches need to add up to 1, flying directly, the FD that I've written there, you can write it what you want, 0.42 and 0.46, so that leaves me 0.12 there. And then the opposite of 0.15 is going to be 0.85, 0.4 is going to be 0.6. Now, I don't have the information for the other branches, so what I could say, one way to do it is to say, well, let's call that x, and this is going to be 1 minus x. We'll worry about that later. The other piece of information that I do have in there is that the overall chance of survival is 0.25. And so I've written that like this: probability of survival is 0.25. And actually, to get that 0.25, I have to go asteroid field and survive, or I have to go outrun and survive, or I have to go fly directly and survive. So it's either that one, or it's that one, or it's that one, equals 0.25. Now, part A of this question, part 1, it says, given that Hank survives his latest chase. So when it says given, that is a conditional probability. And so the notation here, I've got asteroid field, so that he flew into the asteroid field, given that he survives. Now, one way that we can do that is to use the formula sheet, and you notice I've used that notation given, and if I look on the formula sheet, I can see here is this formula here. So A given B is probability of A intersection B over B. So in this one, I could have just done, in the same way, I could have done, well, that's the same as probability of A, F, and S over the probability of S, just using that formula. And so I've got the probability of S is 0.25, and A, F, and S is going to be, that's 0.42 times 0.15. 0.42 times 0.15 out of that, and when I put that into my calculator, I get 0.252.